This is question 8 from the second CSAT sample paper. Here we're given a polynomial f of x, which is x to the n plus a n minus 1 times x to the n minus 1 plus etc. all the way down to a naught, and all the coefficients are integers. And we're told its roots are 1, 2, 4, etc. all the way up to 2n minus 1. We're asked what values can f of naught take. So if you want to have a go at this question yourself, pause the video now. Okay, so how are we going to think about this? Well, first things first, this is all going to be about the coefficients. Bear in mind f of naught is just the last coefficient here. And we can hope that knowing the roots will give us the final coefficient. How can we hope that? Well, because we can try to factorise and then look at what the number term is when we expand out. So that's the way we're going to think about this. So how many roots are there? We've got 2 to the 0, 2 to the 1, etc. all the way up to 2 to the n minus 1. So that's n roots. And this is an order n polynomial, so this is as many roots as it can possibly have. So if we write down one factor for each root, it will be completely factorised. So let's write that down. F of x then, I'll come back to this later. We've got a factor x minus 1, then x minus 2, etc., all the way up to x minus 2 to the n minus 1. And I said this is because it's a degree n polynomial with these n roots, so it's fully factorised. Why did I put this k at the start? Well, that's because in theory it could be any integer multiple of this, so I could multiply it all by 2 and the roots would be the same. But actually, if we go back up and look at what f of x is, the leading term is x to the n. And where does the leading term come from? We just take 1x from each of these brackets, it gives us x to the n, and then multiply by k. So k times x to the n. And that means that since the coefficient here is 1, that means k has to be 1. So we can immediately write k equals 1. So in fact we know f of x exactly, it's just x minus 1 times x minus 2, etc. all the way up to x minus 2 to the n minus 1. And how do we get the number term from that? Well, we just multiply the number terms in each of these brackets. That's minus 1 times minus 2, etc. times all the way up to minus 2 to the n minus 1. And now I just want to simplify this. So first things first, we've got all these minuses to worry about, and there's going to be n of them. So it's going to be minus 1 to the n. And then we've got to multiply all the powers of 2. So I'm writing these powers of 2 as 2 to the 0, 2 to the 1, etc. Because when we multiply powers of 2, we can add the powers. So now I'm just going to add all these numbers to the powers. So I'm adding 0, 1, 2, 3, etc. all the way up to n minus 1. And that's an arithmetic sequence. It's also the n minus 1th triangular number, so you should know the formula is going to be a half times n minus 1 times n minus 1 plus 1. So that just comes to, sorry, I've written it out as the sum of integers. That just comes to a half times n minus 1 times n. When we do n minus 1 plus 1, we just get n. And now this thing at the beginning we can't do anything with because we don't know anything about n. And this we can't simplify anymore, so this is our final answer. So since they asked for f of naught, we'll just write f of naught equals a naught, which is this, and this is our answer.